is Algebra 2, Lesson 9.5, Addition, Subtraction, and Complex Fractions. Beginning on page 562. We're going to add and subtract rational expressions like we multiplied and divided them. Then we're going to simplify complex fractions where we have fractions inside of fractions. That's basically what a complex fraction is. It's a fraction that contains a fraction in its numerator or its denominator. So it's just a fraction inside of a fraction. That's all it is with a complex fraction. Some have variables, some don't. Here we go. Subtracting with like denominators. Anytime you have the addition or subtraction, so you can treat them the same, you have got to have the same, you've got to have the same bottom. You've got to have the same denominator. So in this case, 7x is the same as 7x. Since that's the same, all you do is perform the operation on top, 11 minus 4. So you keep that denominator the same, 7x, and you do 11 minus 4. Keep that denominator the same. You get 7 over 7 times x. So in this case, it says 7 over 7. So you can reduce that one more step. The number 7 goes into those, each of them one time, 1 over x. So again, anytime your denominators are exactly the same with addition and subtraction, it's very, very simple. You just keep the bottom number, perform the operation at the top, and then reduce it if needed at the end. So right here, we had to reduce 7 over 7. On the side of that problem in the margin, let's just do the first one for right now. Just do this one. 3 over 2x minus 7 over 2x. Again, bottom number's the same. Keep it the same. Do the operation at the top. Reduce as necessary. Okay, your bottom number, your denominator is the same, 2x. So we're going to leave it the same, 2x at the bottom. We're going to perform the operation on top, 3 minus 7. You don't need to write this step right here, 3 minus 7. 3 minus 7 is negative 4. Make sure you know that that's negative 4 and not positive 4 over 2x. See right here, we have a common factor in negative 4 and in 2. The number 2 can go into both. It can go into itself once and then go into negative 4, negative 2 times. So we're left with negative 2 over x for that one, negative 2 over x. What about this next one? 3x over x minus 4 plus 6 over x minus 4. Be careful at the end if you have to reduce it. Okay, in this case, your denominator is the same. I said if the number's the same at the bottom earlier, but in this case, you can see the whole expression is the same, x minus 4. So we'll leave that x minus 4 at the bottom. It's common. We'll leave it just like that. And we'll make 3x plus 6. When we add the top number, 3x plus 6. So at this point, you could factor out that top 3x plus 6 since both of these terms have something in common. They both have the number 3 in common. So if we pull that out, 3, it multiplies by x to give you 3x, and it multiplies by positive 2 to give you plus 6. So 3 times x plus 2. And the reason I did that, the reason I factored it out like that, because had it said x minus 4 instead of x plus 2, then we could reduce those two and just be left with 3. In this case, we can't, so there's no more reducing you can do. But that's why you need to do it at that last step like that. Make sure you can't reduce it by factoring it out. Okay. When there are unlike denominators, now just like on our bell work, you have to create like denominators. Now, when there's more than one term, it's somewhat more difficult to do so, but I'm going to show you the easiest way to do it. The easiest way to do it is to factor everything out in order to find the least common denominator. So right here, just looking at the bottoms, 4x and 3x squared plus 9x. 4x can't be factored out because it's just one term. It's a monomial. But 3x squared plus 9x can. We know that the number 3 and x can be taken out of both of those terms, 3 and x. So 3x times x gives you 3x squared, and 3x times 3 gives you 9x. So that right there, that's its factored version, 3x times x plus 3. The reason we have to do that is because we have that binomial x plus 3. The reason we have to do it is because we have to find the least common denominator in 3x and 4x. The number that they both go into, first off, is x. They both have x in common. So we need to have x as part of the denominator. And then, just like we did on the bell work, now we just have 4 and 3. What is the smallest multiple or the least common multiple of 4 and 3? That's right, the number 12. They both go into 12. So our common denominator for both of these fractions, it's going to include this expression right here, x plus 3, and it's going to include x because they both have x in it, and it's going to include the number 12 since 12 is the least common multiple. So right here, this is everything I just did right here, 4 times x, and then 3x squared is 3 times x plus 3. So 12x and times x plus 3. That is the least common denominator. This is the hardest part, absolutely the hardest part of this entire lesson, getting the same denominator for both things. Complex fractions are simple. Once we get to that, that's a simple part of this lesson. Getting the least common denominator. So now, once you have the least common denominator, use it to rewrite the expression. So x plus 2 over 4x plus, okay, that's what we did already. Okay, here, what would happen in these boxes is it kind of skipped a step. It goes from having 12x times x plus 3, which is the least common denominator, no doubt. But down here on this one here, which it shows you both of the denominators, it gave you a broke down version of both of them. Instead of saying 12x times x plus 3, it gives you 4x times 3x times x plus 3, or 4x times 3 times x plus 3, and it gives you 3x times x plus 3 times 4. So I know that all sounds confusing, but you can see that 4 times 3 gives you 12x, and 3 times 4, it's kind of after it. That's why it looks even extra confusing right there. Again, is 12x. So 12x times x plus 3. And there it is there. So on the bottom, in order to make this all work, so this next line, you're looking at this next line thinking, where did this line come from then? What you need to do is you need to multiply it, everything that's the same at the bottom and the top. So, and then just like we did with rational expressions where we canceled out something that was the exact same at the top and the bottom, you cancel it out. So it's easier at this step here, the one that I said that they kind of skip a step. It's easier to make this look like this instead. So here it is right here, x plus 2 over 4x plus x over 3x squared plus 9x. That's your original problem. We said a minute ago that the least common denominator is going to be 12x times x plus 3. And anytime you have a least common denominator like that, we're going to multiply both terms, not both terms, both fractions in this case, by whatever that least common denominator is. 12x times x plus 3. And then we're going to cancel out anything that's the same at the top and the bottom. So right here, this is what's the same. 12, first off, x is the same as x. That cancels out. Then the number 4 goes into both 12 and 4. It goes into itself once, and it goes into 12 3 times. In the other fraction, remember, this is simplified into 3x times x plus 3. So what's exactly the same for this one is x, first off, that's the easy one to see. And then the number 3 goes into itself once and into x 4 times. And then we could clearly see that x plus 3 and x plus 3 cancel out. So what we did, that was, notice all of this is gone. That was this one's equivalent. So everything in this denominator is gone. The only thing that's left over is 4 on that side. Everything in this denominator is gone. You're left with 3 and x plus 3. So I know I made a big old mess right here, but let's look at everything that's still there. We have 3 times x plus 3, and we have x plus 2. That's this fraction here. Plus, on the other one, we have 4 left, and we have times x left. So all we have to do to simplify this is multiply 3x. Now, it kind of acts like, since 3 is multiplying times x plus 3, we have to take care of this before we FOIL. So 3 times x, that should be simple for us, is 3x, and 3 times 3 is plus 9. That all is being multiplied by x plus 2, so we're going to have to FOIL that. And that kind of comes up with one of the more difficult steps right there, to make sure that you do that first. FOIL tells us 3x times x, your first terms, are 3x squared. Oh, your outer terms, 3x times 2 is plus 6x. Your inner terms, 9 times x is 9x. And 9 times 2, your last terms, is plus 18. Then it says plus 4x here. So you have one more 4x. So when we extend all of this, 3x squared is only 1x squared. We have 3 this time, like terms with x to the first. 6x plus 9x is 15x, and 15 plus 4x is plus 19x, then plus 18. And this right here is what we come back to, 3x squared plus 19x plus 18 at the end of all of this. So this is what we should come up with. And since our common denominator was 12x over x plus 3, that's what it's going to be over, 12x times x plus 3. And again, I know I took you through a long explanation there, but this is actually easier than it looks. You have to get a common denominator. Getting the common denominator is the tough part. Cancel out everything. Multiply everything together to get 3x squared plus 19x plus 18, and then put it back over the common denominator. So let's look at one more example like that to see if we can make a little bit better sense out of that problem. So on the back, everybody, this one will look a little bit easier for you. 4 over 3x cubed plus x over 6x cubed plus 3x squared. First thing you do right now, they're not the same on the bottom. Take out the common factors, or factor out that second one. You can see it's a binomial, so factor it out. So what they have in common is they both have a 3 in it, and they both have an x squared. So 3x squared times 3 times 2 gives you 6, and x squared times x gives you x cubed. Then you ask yourself, what do you got to multiply 3x squared by to get 3x squared? Simply 1, so plus 1. So that is that second binomial factored out. Now what you need to do is you need to look at the two denominators and find out, what do you need to include all of them. So we definitely need at least one more x. So because you can see that they both have the number 3. So 3 is going to be included in our denominator for sure. And you need the larger degree of an exponent. So you have x to the third and you have x squared. So we need to include x to the third, whatever one's larger. And it also has the binomial 2x plus 1. This is going to be our common denominator for both of them. The 3, the x cubed, and a 2x plus 1. So that's going to be our final denominator. Multiply this term by both fractions and cancel out everything you can. Do that one for about 30 seconds and then we'll pick back up. So we're multiplying 3x squared, 3x to the third times 2x plus 1 times that one, and we're multiplying 3x to the third times 2x plus 1. And we're going to cancel out everything that they have in common. Remember, this is our common denominator. We'll go back to it in a little bit. We have, for this one, we have 3x to the third. That whole part's gone. So what you're left with for the first fraction is 4 times 2x plus 1. You got to multiply the whole thing. And on the second fraction, when you cancel this out, 2x plus 1 cancels 2x plus 1 out. 3 cancels out 3. And then you have x to the third over x squared. So you subtract the exponents. X to the 3 minus 2 leaves you with just x. So this one's gone, and everything about that's gone. So what you're left with here is x times x, which is plus x squared there. So now all you have to do from here is distribute 4 times 2x to get 8x, and 4 times 1 to get plus 4. Then it says plus x squared. We don't have any like terms at this point, so just reorder it to make it standard form. Put the largest degree first, x squared plus 8x plus 4, and then again it goes back over your original common denominator. It goes over, we said 3x squared times 2x plus 1 for that one. This is your simplified version, even though when you look at that, you think to yourself, that doesn't look very simplified to me. That's it. For this one right here, subtracting with unlike denominators, again, factor out the two bottom things. The first one, x squared minus 1, is the difference of two perfect squares. You make one of them say x plus 1, the other one say x minus 1. So this one here, x plus 1, x minus 1. This one here, when we factor it out, we know we need two binomials, x times x. You got to use 1 and 1. This tells us they're the same sign. This tells us they're both plus. So notice the two denominators here. One I have in red, the other I have in blue. You don't have to represent the same thing twice unless it's already represented twice. And we'll actually pick up with the rest of this lesson tomorrow.